And so we're going to have to look at our x numbers and our y numbers, decide yes there's a constant rate or no there isn't, and then say linear or nonlinear. There are 4 parts. How is x changing every time? Plus 2 every time, right? How is y changing? This one's going up by 4. That one's going up by 12. One's going up by 20. The reason we spend time on quick tables is so you can do that pretty efficiently. Is this linear or nonlinear? Why? This is nonlinear. Because why? There is not a constant rate of change. That is not enough. Remember, they said something about the x and something about the y, because actually x is changing at a constant rate. While x changes at a rate of 2, y increases by a different amount every time. Emily. Because I want you to notice what's happening to x and to y, because in the next chapter you have to pay attention to both of those numbers. And I will tell you that when you're writing technically like that, you do have to be very specific. So I know that in science, when you're doing your lab write-ups, Mr. Windsor continues to talk about using your data to back up your points, right? This, and Mr. Heiler does that in writing. When you're doing writing, you have to use specific details to back that up. That's what's happening here. Because what happens sometimes is that when they say, well, that's going up at a constant rate, someone might say, well, that one's going up at a constant rate. It requires both. That's why it's not. Because technically, x is going up at a constant rate. You need to acknowledge that part of it. But because it's not both of them, it's not. There are 5 total problems on this side. One is a graph. There's 5 more problems to do on this side. Oh, yeah. One of them is a graph. Because we did